Good morning, all of you. We are doing Physics Class 8, Chapter number 3, Motion in One Dimension. We have started the chapter and completed rest, motion, scalar and vector quantity, and the assignment number 1. After that, we have started distance and displacement, then units of distance, displacement, difference between distance and displacement, and assignment number 2. Till now we have completed this. Today we'll start from speed. And first of all, before we start the chapter, we have to know what is speed and what are its unit. So speed of a body is the rate of change of distance with time. Numerically, it is the distance traveled by the body in 1 second. It is a scalar quantity. It is generally represented by the letter small u or small v. If a body travels a distance capital S in time small t, then its speed small v is equals to distance capital S by time small t. So unit of the speed is equals to unit of distance by unit of time. Since SI unit of distance is meter and the time is second, so the SI unit of speed is meter per second, and it is represented as small m s into s to the power minus 1, and in CGS unit is, and its CGS unit is centimeter per second, cm into s to the power minus 1. Now, what are uniform speed? A body is said to be moving with uniform speed if it covers equal distance in uniform speed. Equal distance in equal interval of time throughout its motion. The motion, let us take an example. The motion of a ball on a frictionless plane surface is with uniform speed. Knowing the uniform speed of a body, we can calculate the distance moved by the body in a certain interval of time. If a body moves with a uniform speed v, the distance traveled by it in time small t is given as capital S is equals to v into t. Now, non-uniform or variable speed. A body is said to be moving with non-uniform or variable speed if it covers unequal distance in equal interval of time. Let us take an example. The motion of a ball on a rough surface, the motion of a car in a crowded street, the motion of a vehicle leaving or approaching a distance etc. are with non-uniform speed. Suppose that we are running a car in a very crowded area, in a very crowded street. Suppose that our MG Road in Kolkata, okay, or Bada Bazaar in Kolkata, we will not able to maintain our uniform speed. Sometimes we have to move faster, and sometimes we have to move very slow, or sometimes we have to stop also. Okay, that is non-uniform speed. And uniform speed, a train is moving with its uniform speed. Suppose that 100 km per hour, it is the speed, fixed speed. Okay. Now, instantaneous speed. So instantaneous speed, when the speed of a body keeps on changing. Its speed at any instance is measured by finding the ratio of the distance traveled in a very short interval of time to the time interval. The speed is called the instantaneous speed. Thus, instantaneous speed is equals to distance traveled in short interval time by time interval. Okay, now we will go to average speed. The ratio of the total distance traveled by the body to the total time of the journey is called the average speed. Thus, average speed is equals to total distance traveled by total time taken. Suppose that we have to go from Kolkata to Delhi and the train is taking 15 hours. And what is the distance? The distance of Kolkata to Delhi is 1500 kilometers. So the average speed of the train is 100 kilometers per hour. But after calculating total distance and total time taken, we will get sometimes the speed of the train would be 120, sometimes it will stop, sometimes speed would be 20, 40, 60. This is the average speed. What is the average speed? The average speed is 100 km per hour. In case of a body moving with a uniform speed, the instantaneous speed and the average speed are equal, same as the uniform speed. Now we will move to velocity. Now, what is velocity? The velocity of a body is the distance traveled per second by the body in a specific direction. Thus, the rate of change of displacement of a body with time is called the velocity. It is numerically equal to the distance of the body in 1 second. It is a vector quantity and is represented by the symbol u bar. Suppose that small u and this arrow, or small v, this arrow. These are the vector quantity. So velocity is the vector quantity. Now, what is the unit of velocity? The unit of velocity is same as the unit of speed. That is, the SI unit of velocity is meter per second. It is m into s to the power -1, and the CGS unit is centimeter per second, cm into s to the power -1. Now we will move to uniform velocity. What is uniform velocity? If a body travels equal distance in a particular distance in equal interval of time, the body is said to be moving with a uniform velocity. For example, the raindrops reaches on the earth's surface falling with uniform velocity. A body once started in a frictionless surface moves with uniform velocity. If the body moving with a uniform velocity v to the power arrow and displacement capital S arrow in a time interval t, then by definition v arrow is equals to s arrow by t. Therefore, displacement equals to s capital S to the power arrow is equals to v into t to the power arrow on v. Now, what is non-uniform velocity? If a body moves unequal distance in a particular direction in equal interval of time, or it moves equal distance in equal interval of time, but its direction of motion does not remains the same, then the velocity of the body is said to be variable or non-uniform. Suppose, let us take an example to understand this. The motion of a free falling body is with variable velocity, because although the direction of motion of the body does not changes, but the speed continuously increases. Similarly, the motion of the body in a circular path, even with uniform speed, is with variable velocity, because in a circular path the direction of motion of the body continuously changes with time. In fact, its velocity changes at the uniform rate. At any instance, its velocity is along the tangent to the circular path at that point. Now we will move to instantaneous velocity. It is not here in your syllabus, but I will say a few words about instantaneous velocity. For a body moving with variable velocity, the velocity of the body at any instance is called instantaneous velocity. Now average velocity, it is there, average velocity. If the velocity of a body moving in a particular direction changes with time, the ratio of displacement to the time taken is in entire journey is called its average velocity. Thus, average velocity is equals to displacement by time, total time taken. So, displacement, so how far it is displaced. Suppose from a body moves from A to B. This is known as displacement and this is known as distance. Okay, the smallest distance is known as the displacement. And how much time taken from going from here to here? It is total time taken. So this displacement by total time taken is equals to average velocity. Okay, now we have to know the difference between speed and velocity. What are the difference between speed and velocity? The distance traveled per second by a moving object is called speed, and velocity, the distance traveled per second by a moving object in a particular direction, is called its velocity. In speed, it is scalar quantity. The speed does not tell us the direction of the motion, but in velocity, it is a vector quantity. The velocity tells us the speed as well as the direction of the motion. Now in speed, after one round in a circular path, the average speed is not 0. Then after completing each round in a circular path, the average velocity is 0. As we know that we have completed speed and velocity, there are some examples, that means some numericals are given. You have to practice it at your home. Today we will start again in acceleration. Now acceleration, what is acceleration? Acceleration is the rate of change of velocity with time. Thus acceleration is numerically equal to change in velocity in 1 second, that is acceleration is equal to change in velocity by time interval. Okay, suppose here one example is given, station A to station B, velocity increases, here velocity increases, then constant velocity, then velocity decreases. This is non-uniform motion of a train between station A to B. These changes in the velocity of the moving body are described in terms of acceleration. Acceleration is denoted by small a and is defined as follows. The change of the velocity of a body per unit time is called acceleration. Here what is changing? Sometimes this velocity of the train is increasing, sometimes it is constant, and sometimes it is decreasing. Okay, now units of acceleration is equal to unit of velocity by unit of time. The unit of velocity is meter per second and time is second. Therefore, SI unit of acceleration is meter per second by second. That means is equals to meter per second square, or meter into second to the power minus 2. The CGS unit of acceleration is centimeter per second, centimeter square per second. Now relation between accelerations. Relations for acceleration. What are the relations for accelerations? Whether it is given. Let us see some relations. Let a body be moving in a straight line in one direction with an initial velocity small u. Its velocity changes in a short time interval small t, and the final velocity becomes small v after time t. Then change in velocity is equals to small v minus u, and the time taken is equals to t. Therefore acceleration is equals to small v minus u by t, or v is equals to u plus at. This is the relationship. If v greater than u, then small a is positive, thus small a is the acceleration. But if v is less than u, then a is negative and a is the retardation. So negative acceleration is known as retardation. Okay, now we will move to retardation. As we know that negative acceleration is also called deceleration or retardation. So when the velocity of a body increases with time, it is said to under retardation. And retardation has the same unit of acceleration, that means meter per second square. Okay, now we will move to uniform acceleration. Uniform acceleration. The acceleration is said to be uniform or constant when equal changes in velocity takes place in equal interval of time. The motion of body under gravity is an example of uniform acceleration motion. Now variable acceleration or non-uniform acceleration. If change in velocity is not same in the same interval of time, the acceleration is said to be variable or non-uniform. The motion of a vehicle on a crowded or hilly road is the variable acceleration. As we have already discussed, the example of the average speed, that is same here. Now acceleration due to gravity. When a body falls freely under gravity, the acceleration produced in the body due to Earth's gravitational attraction is called acceleration due to gravity. It is generally denoted by the letter small g. When a body falls down, its velocity increases with time, so the acceleration is plus j, while if the body moves vertically upward, its velocity decreases with time, so the acceleration is minus j or retardation. When we throw a ball upwards, when we throw, the velocity is very fast, but when it reaches the top point, its acceleration is 0, and after that it will coming down to the ground. Okay, because of the gravitational pull. Okay, now the average value of j is 9.8 meter per second square, or nearly 10 meter per second square. Actually it is vary from place to place. Thus, if a body falls free under gravity, its velocity increases at the rate of 9.8 meter per second square. That is, starting from rest, after 1 second the velocity would be 9.8 meter per second. After 2 seconds the velocity will be 2 into 9.8, that is 19.6 meter per second square. Similarly, after 3 seconds the velocity would be 29.4 meter per second square. Okay, so we have completed our assignment number 3, that means speed and velocity. So you have to do these exercises, this assignment number 3 at your home. Next day we will start from graphical representation of linear motion. So do the assignment and read the chapter. Till then, goodbye. Thank you.